Hello, and welcome to Aerotech's Automation 1 Motion Control Platform Educational Series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation 1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, you will discover how to migrate the parameter file of your A3200 system to the newer Automation 1 format. For migrating the A3200 parameter file, we are first going to need the A3200 to Automation 1 migration zip file. This can be found on our website or in the Automation 1 help file from our website, where you can download it and extract the contents. So in the help file, under software migration from A3200 to Automation 1, we'll find another section called Migrating the A3200 configuration. Under Migrating the A3200 configuration, we'll find a drop-down, and under that, we'll find the A3200 to Automation 1 migration zip file. And once we have this file downloaded and unzipped, we can take our A3200 parameter file and copy it into the A3200 parameters to Automation 1 subfolder. So in this zip file, once you extract it, you'll find the A3200 parameters to Automation 1 subfolder. Take your parameter file and copy it into that folder. Then go into that folder, find the parameter file you just copied, in this case my BMS60_Pro165LM test file, and click and drag that up to the A3200 parameters to Automation 1 executable. This will open a command prompt-like screen letting you know if there's any errors in migrating the configuration file. In this case, I don't see any errors here, so we can just press any key to continue. And after we do that, we can see that my BMS60 parameter file has now been migrated to a BMS60Pro165LM MCD file. That is the new Automation 1 format. And now that we have this MCD file created, feel free to copy or move this to a new location. Next, we're going to go into the Automation 1 Studio and continue on and finish up the MCD file creation. So now, once we are in the Automation 1 Studio, let's go to the Configure tab and go to Administration so we can upload the new MCD file we just created. Next, let's go through the Upload MCD file window to finish uploading the MCD file we just created. So we'll step through here and go through the MCD configuration. This includes our parameters and machine setup files, so we'll have that upload. The existing configuration, we will retain all other configurations such as hyperwire, controller name, and access control. Next, our controller files, or any files that are currently uploaded into the Automation 1 file system. We're going to retain those as well. And finally, any machine apps or machine apps configurations will retain those as well. So here, all we're doing is just uploading the new parameters that we just created. This finishes uploading the migrated MCD file we just made. However, despite having the MCD file created, we are not done yet. While the migration tool we use does copy and update many parameters for Automation 1, this does not fully complete the system migration process. Due to the behind-the-scenes differences between A3200 and Automation 1 architecture, some of the A3200 parameters are different in Automation 1, and thus we must manually configure these parameters based on our system. The parameter types that do not get migrated using this migration tool include the encoder feedback resolution, current loop, servo loop, and feed-forward configuration parameters, as well as some autofocus and analog I/O filters. Some of these parameters will be taken care of with a little retuning, however some will also need to be manually configured, primarily the current loop parameters, feedback resolution, counts per revolution, and cycles per revolution parameters. We have two options for reconfiguring these types of parameters. One, we can actually manually reconfigure the parameters. This would involve manually calculating out those parameter values, such as the feedback resolution, and inputting those into the new MCD file. The other method is to just use the machine setup tool to automatically complete and fill in these missing parameters. For most scenarios, I would highly recommend using option number 2 since it is more encompassing. This is because the machine setup tool walks us through configuring a stage from start to finish and will automatically fill in any missing parameters we might have. Manually adjusting the parameters through option number 1 requires a little bit more knowledge of how the stage functions and its specifications, so I would recommend using the machine setup tool to finish completing the configuration. Machine setup also has the added benefit of giving us some starting tuning gains and is still more all-encompassing regardless of whether or not it's an Aerotech product or third-party stage configuration. To give you an idea of what manually reconfigured the parameters through option number 1 will look like, however, let's look at something like the counts per revolution parameter from A3200. This is a crucial parameter that dictates how many encoder pulses the drive should be seeing per revolution or per electrical cycle of a motor. This was renamed to the primary feedback resolution parameter in Automation 1. Manually calculating this for A3200 involved needing to know several factors and then calculating out the proper numbers. Automation 1 is no different. For our examples, we are just going to be assuming either a standard analog or digital encoder. Absolute encoders, while supported, might have a slightly different process. So for something like a rotary stage, the primary feedback resolution parameter still consists of finding the encoder lines per revolution specification of your encoder, then multiplying it by either a multiplication factor or multiplying it by 4. Analog encoders would multiply the lines per revolution specification of your encoder by a multiplication factor, which is dictated by another parameter in the parameter file. Digital encoders, on the other hand, would multiply it by 4 because of the quadrature nature of the digital encoder. For linear stages, on the other hand, we would need to calculate the effective encoder resolution of your encoder in microns for the primary feedback resolution parameter. For this, we would take the encoder resolution from our encoder data sheet, such as 20 microns, and divide it by your multiplication factor, which is this other parameter in the parameter file. For instance, if you have a multiplication factor of 2000 as indicated by the primary encoder multiplication factor parameter, and an encoder resolution of 20 microns, enter 0.01 microns as the resolution. If your linear encoder is a digital encoder and doesn't actually require a multiplier, then your multiplication factor is just equal to 1. So your 20 micron encoder, you would just enter it as 20 microns. If the motor is a linear motor, then the motor pole pitch parameter will be in millimeters, and you can generally find this specification in the motor specification sheet. In this example, the BLM 142 motor has a 30.48 millimeter magnetic pole pitch. For rotary stage, you would just enter the number of poles in the motor as also dictated by the motor specification sheet. So in this example, a BM130 has 8 poles in the motor, and those would be the values that you would enter for the motor pole pitch parameter. And lastly on our list of parameters that we need to keep in mind while migrating are the servo and current loop parameters. These are the last of the quote required parameters. Autofocus and analog I/O filters, while helpful if you are using them, are not necessarily required to get the axis running. Most likely you will do these parameters by retuning the stage. However, if we are looking at trying to find a starting point, then we can look at how to manually reconfigure them. So starting with the current loop, manually reconfiguring the current loop from scratch will just mostly require us using the frequency response tool in the Automation 1 Studio to plot and tune a bode plot of the current loop response. And for information on how to do this tuning, I'd highly recommend looking at the tuning section of the migration process. This section here is just supposed to give you an example or a starting point for how the parameters should be migrated. Next is the servo loop. Tuning from scratch on the servo loop, however, will require a little more determination on some other secondary parameters. These will be the servo loop gain and feed forward gain normalization factor parameters. Then after we figure out what those should be, you can either use EasyTune, classical tuning, or the frequency response tools to tune your stage or motor. EasyTune is by far going to be the easiest method out of the three for doing this. Now, calculating these normalization factor parameters is going to be the hardest part. This can certainly be more involved than the other parameters and more dependent on different stage variations like direct drive linear stages, ball screw driven linear stages, or gear driven rotary stages. And those specifications on how to do each one of those are going to be a lot more in detail than we can go into this video. So for those parameters, I would just like to refer you to the respective help file pages for the servo loop gain normalization factor and feed forward gain normalization factor parameters. As an example though, here's a sample of what would be required for calculating the servo loop normalization factor for a direct drive linear stage. There are other different variations of this for the different stage variations like ball screw or gear driven rotary stages. And all of these different variations and calculations can be found in the respective help file pages for the servo loop and feed forward gain normalization factor parameters. Now, on the other hand, if you decide you want to just use the machine setup tool, that is definitely the recommendation I would have. Doing this is going to be a lot easier and is going to fully configure the rest of the stage for you. All you will need to do is go to the Machine Setup tool, enter your stage specifications and configuration, and then it'll output the proper configuration file and parameters for you to use. So let's go through the Machine Setup tool to give you an idea of how much easier this is going to be. Under the Configure workspace, go down to Machine Setup. Now, I will be doing all of this with virtual axes, so you should see something slightly different, but overall it's going to be the same. Work through until we'll get to the electrical devices section. This is where the drives are going to be shown. Now, everything except for the bus voltage should already be filled in for the drives that you have selected. If you don't have any drives actually selected and you're also doing this in virtual mode, you're going to have to use the Add Device button to go through and add some devices. Next is the mechanical devices section. We're going to add a device, and like the parameter file I used before, I'm going to select the BMS60 motor. Give it a couple options here. And the Pro 165 LM stage. Now, those two are Pro 165 LM and BMS60 motors. We'll move to the interconnectivity section and click and drag our stages to the proper axes. Now, depending on if these are analog or digital encoders, we may be asked for multiplication factor. And next, we'll have the summary page. This is going to show us all of the parameters that are going to be changed by the Machine Setup tool. Now, some parameters we don't actually want changed. Some parameters like default ramp rates and speeds, homing configurations, we'll want to keep those from our A3200 parameter file. So the migration process copied all of those files correctly. All we want to do is use this Machine Setup tool to configure and copy the parameters that were not able to get migrated using the migration tool. If we leave all of these parameters selected, then the Machine Setup tool will revert all of these parameters back to their default values, and that may not be what you want for your final system. So we will deselect all of these and then go through and only select the parameters that we needed to migrate manually. So that would include the current loop gains, the primary feedback resolution, the motor pull pitch, the feed-forward gains, feed-forward gain normalization factor, servo loop gains, and servo loop gain normalization factor. All of the other parameters we're going to want to keep since those were carried over from our previous A3200 configuration, and we don't actually need to reconfigure those. We'll do that for both axes. And then we will complete the machine setup process. And that completes the machine setup process. Afterwards, I'd recommend using the checklist on the right-hand sidebar to go through and finish configuration and just to make sure all the parameters are properly set and what you need them to be. Otherwise, at this point, your parameter file should be fully migrated from A3200 to Automation 1. The only thing you may need to do now is run through something like easy tuning to finish the actual tuning process. Machine setup will just give you some initial tuning values to use, but you may still need to go through and do more manual tuning to make sure that your axes are fully tuned and fully optimized for your system. And so then that concludes this motion control platform educational video. Thank you for watching, and I hope you enjoyed learning about how we can migrate your parameter file from A3200 to the new Automation 1 format.